Hello and welcome to this new video series in which we discuss the root finding methods. Roots are values at which a function f of x equals 0. Root finding methods are essential tools for solving many problems in engineering, science, and finance. Therefore, it is important to understand how these methods work. In the next slide, we will learn about the two categories of the root finding methods, and then in the coming videos, we will talk about several methods from these categories individually and use Python to write programs for each of these methods to see how these work. Root finding methods are typically classified into two categories, bracketing methods and open methods. Bracketing methods require two initial guesses that bracket the root. In this example, there are two roots of the function f of x, so we have to provide two guesses per root. Since we begin with the knowledge of the lower and the upper bounds of the interval that contains the root, the bracketing methods always work, but they might converge slowly. To explain how bracketing methods work, we'll focus on the root at x is equal to 2. So we start with the lower and the upper bounds. Then depending on the method, as each has its own way, we get the next estimate. Now we evaluate the two intervals which are on the left and on the right of the estimate for a sign change. In this case, we see the sign of the function changing in the interval to the right. So we keep the right interval and make another estimate of the root, and iterate the process until a user-specified criterion on precision or the max number of iterations is met. Examples of bracketing methods include bisection and the false position methods. Open methods, on the other hand, can involve one or more initial guesses, but these are not required to bracket the root. Open methods can therefore converge faster than the bracketing methods. Let's say we start with the initial guess. Using the derivative or an approximation to the derivative at the estimate, we can find the next estimate, and by doing so, we can converge to the root in a much faster way than the bracketing methods. These methods require the initial guess to be closer to the root value and may fail to converge if the initial guess is not close enough. Examples of open methods include Newton-Raphson, secant, and modified secant methods. With this, we conclude our video. In the next video, we will see how we can automate finding the intervals that bound the root, which can further help these methods finding the roots efficiently for functions with more than one root. Thank you and see you in the next video.